Dear students, welcome to my next class on crystal field theory, CFT. It's called crystal field theory. Means in this theory, going to learn about why the different kinds of ligands are classified into strong field ligands and weak field ligands in deciding the geometry, deciding the magnetic property of the compounds in the coordination complexes. Let us see the important things which are discussed in this crystal field theory. In this theory, M stands for metal ion, L stands for ligand, and between them we are going to discuss coordinate bond or covalent bond, coordinate covalent bond or dative bond. According to this theory, this bond is purely electrostatic interaction is the assumption. Other one is ligands are treated as point charges when they are anions. When they are neutral molecules, they will be considered as dipoles. The other thing here is these ligands are deciding the geometry when they are approaching the metal ion. What will happen is the degeneracy of the d-orbitals present in the metal will get disturbed. That's why that will gives the splitting of d-orbitals phenomena called as crystal field splitting. So, in the neutral state of the d-orbitals of metals, how the degeneracy is maintained, average energy of the d-orbitals will get little bit raised when the ligands are approaching metal. Ligands are approaching metal along the axis. Along the axis, ligands are approaching metal in between the axis. In between the axis. These are two types of things which are frequently happens in the octahedral complexes and tetrahedral complexes of these coordination compounds. So, this is exclusively studied in two types of complexes. The one type of complex is called as octahedral complex study. The other type is called as tetrahedral complex study. In the octahedral complex study, the ligands are said to be approaching metal along the axis. Then that 5 d-orbitals we have dxy, dyz, dzx, dx square minus y square, dz square are said to be splitting into two different groups. One is called as EZ group, another one is called as T2Z group. The EZ group will get more energy because the orbitals dx square minus y square dz square having lobes along the axis will experience more repulsion due to the ligand approach along the axis. In this other type of the d-orbitals dxy, dzx, dyz, where the lobes are present in between the axis will experience lower energy. So that energy is noticed with delta naught for the octahedral complexes, whereas the barrier is there, energy barrier. The barrier is noticed with delta naught, and the rise in the energy of the EZ orbitals is 3 by 5 delta naught given, and decrease in the energy of T2Z is given as 2 by 5 in this crystal field octahedral complex study. Let us talk about the tetrahedral complex study where Ml4 is the general formula of this case. In this, which orbitals are present in between the axes like T2Z are said to be experiencing more energy in the T2Z, which is completely inverted picture of that of octahedral in the tetrahedral. But comparatively, tetrahedral is having a smaller energy differences than that of octahedral, which was given as a mathematical formula, that is delta T is equals to 4 by 9 delta naught, means 9 into delta T is equals to 4 into delta naught, means you can understand octahedral complexes are said to be higher energy than the tetrahedral complexes. Means in this we will going to study about a type of ligands which are strong field ligands. These type of ligands are said to be weak field ligands. So ligands can be classified in terms of this crystal field splitting. In this theory is given to us a clear cut idea why the rearrangement of the d-orbitals electrons taking place in the presence of strong field ligands and making the complexes diamagnetic, and tetrahedral complexes and all this study is talking about weak field ligands. Those are not giving any kind of rearrangement of d-orbitals and paired electrons in the central metal of the complex compounds. This is what a small approach of the crystal field theory talking about the ligands in this study. So next video we are going to discuss about the different kinds of ligands according to crystal field theory, how they have given in increasing order or decreasing order of field strength in the next video. Until have a nice day. Thank you.